Welcome back from the ad break, and let's continue with our lesson. Let's look more into those application questions. So now we are not just going to be listing properties, but let's compare these different parallelograms. Our first question there says, explain why a rhombus is a special kind of parallelogram by comparing the properties of both quadrilaterals. So yes, a rhombus is a special kind of parallelogram. So let's see how we can explain why the rhombus is a special parallelogram. Now, when we think of the properties of a parallelogram, then we know that with a parallelogram, it has two pairs of parallel sides, which are also the same properties for a rhombus. Now, what we know about a parallelogram is that the opposite sides of a parallelogram are equal. So we know that the opposite sides of a parallelogram are equal. Now here's where the difference comes in with a rhombus. Yes, the opposite sides are equal, but in a rhombus, also all the sides are equal. So this means that not only are the opposite sides equal, but also the adjacent sides are equal as well. So this is what makes a rhombus a special kind of parallelogram. Now, it is not only the sides that make the rhombus special, but it's also when we are looking at the diagonals of these two quadrilaterals. Now, the diagonals of a parallelogram, yes, they bisect each other, right? Which is also true for a rhombus. Yes, they bisect each other. But now what makes the diagonals of a rhombus special? It's because they bisect each other at 90 degrees. So they bisect each other at 90 degrees. With a parallelogram, the diagonals are not perpendicular, but with a rhombus, the diagonals are perpendicular. The last difference, or the last thing that makes, the last property that makes a rhombus special is that the diagonals, they bisect those opposite angles. So those opposite angles are cut in half, they are bisected, they are divided into two equal parts, and that is only with a rhombus. It is not the case with a parallelogram. So this is with both pairs of opposite angles. They are bisected by the by the diagonals of the rhombus. So that is why a rhombus is a special kind of parallelogram. So all the properties of a parallelogram, they apply to the rhombus as well. It's just that a rhombus has more properties that make it special. Let's move on to the next question. It says there, explain why a square is a special kind of rhombus, rectangle, and parallelogram by comparing the properties of these quadrilaterals. Now, we are going to be looking at a square. Now, when looking at a square, we need to see what makes it special, because a square is a special rhombus, a special rectangle, and also a special parallelogram. Now, by special, we would mean that all the properties of a parallelogram apply to a square, all the properties of a rectangle apply to a square, and all the properties of a rhombus apply to a square. So let's see how this is possible. Now we are going to be looking at a square, and we are going to be comparing that with a rhombus, and we are going to compare that with a rectangle, and lastly also with a parallelogram. So now, of course, we know there that, let's just redraw that rhombus. So we know that with a parallelogram, we know that the opposite sides are parallel. And of course, those are all the things that apply to a square as well. So we have the opposite sides parallel as well. So that's what makes a square a special parallelogram. Then again, with a parallelogram, we have the opposite sides being equal. And of course, with a rhombus, with a square, that is the same thing, the opposite sides are equal. But now what makes it special is because all of the sides are equal. So they are not just two opposite sides that are equal, but all of them are equal. Now that makes us think of a rhombus, because when we think of a rhombus, the opposite sides are also parallel. And all of the sides are equal. So definitely we can say that a square is a rhombus as well. But now what makes it a special rhombus? Let's continue looking at our properties. Now we know that with a parallelogram or a rhombus, that the opposite angles are equal. So we know that the opposite angles are equal. This is the same for a parallelogram and a rhombus. The opposite angles are equal. Now this is also true for a square. The opposite angles are equal. Now what makes a square special is that all of the angles are equal. And not only are they equal, but they are 90 degrees as well. Now, when it comes to a rhombus and a parallelogram, we know that the opposite angles are equal, but they are not all equal, and they are not equals to 90 degrees. Where they are equals to 90 degrees, that is with the rectangle. Now, the rectangle also has the same properties as the others. That is why, as the other quadrilaterals that are here on the screen, that is why a rectangle is also a special parallelogram. But now, what makes a square special? So let's look at the rectangle. The rectangle also has 90 degrees as all of the angles. It has the opposite sides to be equal. It has the opposite angles the opposite sides to be parallel as well. But what makes the square now also a special rectangle? We've looked at the sides, we've looked at the angles. Let us now look at the diagonals. Now, the diagonals of any of these parallelograms that are here, they bisect each other. So the diagonals of a parallelogram bisect each other. The diagonals of a rhombus bisect each other. The diagonals of a rectangle bisect each other. But now, the diagonals of a square also bisect each other. The diagonals of a rectangle, not only do they bisect each other, but they are also equal, something that is not true with a rhombus and a parallelogram. So with a rectangle, the diagonals are equal. Now the same is true with a square. The diagonals are equal. But what makes a square different or special than a rectangle? It's because the diagonals, they meet at 90 degrees and they bisect the angles as well. So not only do they meet at 90 degrees, they bisect the angles as well. So those are the properties of a square. It has two pairs of opposite sides, two pairs of opposite sides that are equal, two pairs of opposite sides that are parallel. The angles are 90 degrees. The diagonals are equal and they meet at 90 degrees and they bisect the opposite angles. So that is how a square is a special kind of rhombus, a special kind of rectangle, and also a special kind of parallelogram. Let's move on to the next question. So the following quadrilateral is given with AB is equals to BC, is equals to CD, is equals to DA, and that is equals to 5 centimeters. So basically, we are told that all of the sides are equal. And remember, we are just told that it's a quadrilateral, but we do not know what quadrilateral it is. Based on the properties, because all of the sides are equal, it could either be a square or a rhombus. Let's look at more information. AC is a diagonal, as we can see. Angle B is 90 degrees as shown in our diagram. Now, what does that mean? Remember, we said all the sides are equal, meaning it is either a square or a rhombus. But because one of the angles is 90 degrees, this automatically makes it a square. Now let's calculate the size of P and Q. Now let's look at where P is. P is at angle D. And because we've said that this is a square, that means that angle D is 90 degrees. So P is equals to 90 degrees. And the reason for that is that these are angles of a square are equal to 90 degrees. Then let us calculate our Q. And in calculating our Q, we are looking at where Q is. Now Q is also part of angle C. Now we already know that angle C is 90 degrees, and this is because this is a square. But now AC is a diagonal. And what do we know about the diagonals of a square? The diagonals of a square, they bisect the opposite angles. Now, if C is 90 degrees, that means that Q is equals to half of angle C. And that is because the diagonals of a square, we can just write there that actually AC bisects angle C. So that means that Q, or the angle there at Q, or Q, is equals to 45 degrees. Now why is it 45 degrees? Because angle C is 90 degrees, and when we bisect angle C, we get Q, which is 45 degrees. Let's go to an ad break and then we'll see you just now.